All right, 4.7 inverse trig functions is our topic for this video session. And so inverse trig functions, we're finally going to get to all of those -1 functions. Sine -1, cosine -1, tangent, etc., etc. The other way we can say these things instead of -1 is the arcsine theta. That's the same as saying -1. And that's also the same as saying the inverse sine. All right? And so what we've done so far is we've had an angle, say 45 degrees, and as a result, we've gotten a side length, right? The opposite, if we drew a triangle, would be √2, and the hypotenuse is 2. So the input is an angle. The output is a fraction of sides of a triangle. The inverse is the reverse, right? So to go to an inverse function, we switch our inputs and outputs. So now our input is going to be the fraction of the sides of a triangle that we make, and the answer, the output, is going to be whatever angle is created inside of that triangle. So we're reversing what we're doing. So if we want the angle, we're going to use the inverse trig function, be it sine or cosine or tangent. All right? So that's the way I remember it. If I want the angle, use the negative sine. If I want the angle, use the negative cosine. So let's try a couple examples here. We're going to say arcsine of -1/2. So what we're going to do is we're going to go on our unit circle and find the, remember, on the unit circle, sine is y over r, and on the unit circle, y over 1, so sine is just y. So we're going to go to the unit circle and find an angle where the y value is -1/2. So let's flip over here, and here's our unit circle. I see one down here. And I also see another one over here, so quadrants 3 or 4 will both work. For all of these problems, we're going to use just quadrants 1 and 4 for y, and we're just going to use quadrants 1 and 2 for x. So we're not going to be over here in quadrant 3 for these answers, because quadrant 3 will give us a repeat, a second answer. We're just looking for the first one. And so we're going to come over here, we find 330 degrees is the angle that gives us a y value of -1/2. So we can come back in here, and that would be our answer, 330 degrees. Okay? Now we can also give that in radians. That would have been 11 pi over 6. All right, either one will work because we're looking for the angle. All right, let's flip back over and find the sine, find the angle where the y value is √3/2 for b. Flip over here, looking for √3/2. Go up here, we'll find it up here at 60 degrees. So our answer for b would be 60 degrees. That's the angle. If I flip back, that's the angle where the y value is √3/2. And we're looking for y because the problem asks for sine. All right, last one, sine -1 of 2. Let's go over here and look at the unit circle. See if you can find the y value, the angle where the y value is 2. And you shouldn't be able to find it. It's not going to be there anywhere. Remember, this is sine -1 of opposite over hypotenuse. Is there ever a situation where opposite could be 2 and the hypotenuse could be 1? Can't have the hypotenuse not be the biggest side. So this is going to be undefined. Right? You cannot have an inverse sine value bigger or smaller than 1 or -1. And that's what this is showing up here. All right? Our answers have to be in between, our inputs have to be between -1 and 1. All right, see if you can try this on your own then. Find the arcsine of 1/2. All right, if you went over here and you said the arcsine of 1/2 is 30 degrees, you are 100% correct. It's the place, the angle, where the y value is 1/2, and that happens to be 30 degrees. All right, let's also move on here and look at the graph here for example 2. I'm just going to throw this up here. I'm not going to have you be graphing inverse functions very much. I just want you to see them. If you notice here, our graph, this is our normal sine graph. All right, so here's our amplitudes, -1 and 1. Our normal period would come back up here to 2 pi. And so to graph the inverse, what we're going to do is switch the x and the y's. And so it'll look like that. And so we're just going to do the period from here to here, because once we get to that point and we start going back down again, if we rotated that, all of a sudden we would start coming back up this way, and it wouldn't be a function anymore. It wouldn't pass that vertical line test that we used to have. All right, so we're just going to rotate just a piece of it, and it'll look like that. So that's all I really need you to know about graphing the inverse sine. Same thing with cosine curves. Okay? So for our next problem here on 21, it says use a graphing utility to graph f, g, and y equals x in the same viewing window. Again, the important thing here, y equals x is a diagonal line like that. Okay, our sine curve, if we flip back, the important part that we're dealing with starts low and finishes high. It should look like that. Okay, and so our inverse is going to be flipped around this, and it's going to look like that. Okay, and so it's symmetric along the line y equals x. All right, don't need to memorize this. I just want you to have seen it once. Understand that when we do the graph of the inverse, we're rotating about the line y equals x. All right, so we will have symmetry there. Let's move on then to example 3, working with some of the values. So find the exact value of arc cosine of root 2 over 2. So for all of these, we would flip back to our unit circle if we needed to. At this point, though, I'm expecting you to start to have that unit circle fairly well memorized. So you should at this point be able to tell me where on the unit circle do we have an x value of root 2 over 2? If you said 45 degrees, you are in business. Okay? Cosine -1, that's the same as saying arc cosine. Where on the unit circle is the x value -1? If you said 180 degrees, you are on top of it. All right, let's think about tangent. Tangent's the place where we have y over x. This must be 0 over 1. So we're trying to find an angle where the y value is 0 and the x value is, really it could be anything else, but can we find a place where y is 0 and x is 1? If you went and found 0 degrees, you are all over it. And last one, tangent of -1. We need y over x to be a -1 over 1, or negative anything over itself. Okay? So if you'll notice, I do have these, root 2 over 2 and root 2 over 2. Okay? See if you can find in either quadrants 1 or 4. All right? 1 or 4, the angle where the y value is negative root 2 over 2 and the x value is root 2 over 2. Got it? If you found it at 3:15, you've got this figured out. All right? See if you can do one on your own. Find me the arc cosine of -1 over 2. All right, the place where the x value is -1/2 is going to be a reference angle of 60. Which means that it is at 120 degrees. This is -1/2 root 3 over 2. And we're looking for the x value of -1/2. So 120 degrees would be your answer for example for problem 15.